Hello. Today we are going to talk about an interesting observation in fluid mechanics, which is about blowing under an index card. Basically, at the beginning, we are going to explain the procedure and the observation of the experiment. Then, we are going to provide an explanation why a folded note index card will not fly into the air while we blow under it. Then, we are going to provide an appropriate analysis and describe the process based on Bernoulli's equation. We're going to sum up everything in the conclusion and confirm our results. If you've ever done homework outside, it's more than likely that you've had to deal with your papers flying everywhere because of the wind. In most cases, this is just an inconvenience. Post some folding and the proper orientation, what we will really have is an interesting demonstration of the Bernoulli equation. First, make the index card stand up on its own by folding the edges, then place it on a flat surface and set it in front of any source of air. What you will notice is that no matter how fast the air is moving towards the index card, it will not fly away. In fact, if the air is moving fast enough, the portion of the card parallel to the flat surface will even be pulled down towards the surface, the opposite of what you would think. Here's a video we created to demonstrate this occurrence. While the air hitting the card isn't moving fast enough to pull it towards the surface, it's clearly visible the card remains static. Based upon our knowledge of fluid mechanics, the hypothesis for blowing on a folded note card is that due to the elevation change between points 1 and point 2 being negligible, there will be no lift on the note card when someone blows on it. We use Bernoulli's equation to form this hypothesis and set 2 points on the model. One within the surrounding volume of the card, point 1, and one outside and directly on top of the note card, point 2. Our hypothesis also assumes that V2 is equal to 0 in the Bernoulli equation, meaning the air outside the note card is static. Now, using this equation, we can see in the middle of our slide here, with our assumptions, Z1 is equaling to Z2 and V2 equaling 0. That any fluid with any velocity moving underneath the card will result in a lower pressure within the area. This imbalance of forces pushes the cards down and prevents it from blowing away in the wind. With these results, we can see that we correctly hypothesized that with the velocity flowing, the decrease in pressure inside is what actually happens, as we saw in our experiment. I hope you learned something today from our talk. Thank you.